Hello guys, in today's class we shall discuss about the topic current setting. We know that our overcurrent relay will operate only when the operating current exceeds 5 ampere if the relay is set at 5 ampere. If current is below 5 ampere, then relay will not operate. It is just for an example. So there are number of tappings given on the current coil available on the relay setting. So the operation of relay requires certain flux as well as ampere turns so as to operate. Now current settings of the relay are chosen such a way that by using plug setting. Thus by varying the plug setting we can set the different current values. You can set the current setting directly in amperes or indirectly as percentage of rated current. This you learn very much in clear while doing relay and high voltage laboratory. So an overcurrent relay is used for line to line fault protection. Usually it is set in between 50 to 200% of the rated current in steps of 25%. So if the relay is of current rating 5 ampere, so then it can be set to 2.5 ampere or 3.75 ampere or 5 ampere or 10 ampere. So when a relay is set to 2.5 ampere, it will operate only when the current exceeds 2.5 ampere. If current is less than 2.5 ampere, then relay will not operate. So the relay is also used to protect against any ground faults or any you can call earth fault relay, which has settings usually in between 20% to 80% in steps of 10%. So in such a case the current rating of earth fault relay will be usually 1 ampere. So if we plot time current curves, that is on x-axis we are going to multiply plug setting multiplier. We are going to write plug setting multiplier. This is a logarithm scale, and on the y-axis we are going to write the operating time in the seconds. So this is also inverse time characteristics. So there will be one graph for each setting of the relay. Say if you are setting for 25% of the rating of the relay, or if you are saying 50%, if you are saying 60%, then curves will be different. They will not overlap. Depending upon the settings, you will get the numerous number of graphs. So this is how we are going to calculate the plug setting multiplier. It is the ratio of secondary current divided by relay current setting, the setting which you are going to do that. There are plugs provided on the relay. So one more formula for this secondary, instead of secondary current you can write it as primary current during fault, otherwise you can call it as fault current. You can decide the fault current and you can set the plug setting. So can easily calculate what will be the plug setting multiplier divided by the relay current setting into current transformer ratio. Current transformer ratio, everything it will be given, and depending upon the fault current you are going to decide there, and you are going to set the plug setting multiplier. You can going to calculate this. So that's why plug setting multiplier, time current characteristics. So that's why plug setting multiplier is taken on the x-axis, whereas time is taken on the y-axis. This plot is generally plotted on the log. Okay. So now let us see the next topic, that is time setting. In the last topic we saw current setting and how current can be set with respect to plug setting multiplier and all we saw there. So in this topic I am going to set the time here. So the desired operating time for the relay can be set at any desired value. Usually we do in induction disc type of relays, the angular distance which the disc covers after fault and all, so that duration can be controlled. The duration can be set, set for different operating time. There are usually 10 steps in which time can be set. So it is called as time multiplier setting. Sometimes it's also called as time setting multiplier. So it is used in terms of steps for setting the time. Usually the values of time, that is TMS, are in terms of 0.1, 0.2, 0.3, 0.4, like this, so on to 0.9 as well as 1. Let us take a particular instant. Let us say our plug setting multiplier we have set for so and so value, and the operating time is 4 seconds with respect to TMS equal to 1. Let us say if I set time setting multiplier 1 means, let us say the operating time is 4 seconds. Let us take a case. So the operating time for the same current, that is plug setting multiplier, so if I want to reduce it, then I have to reduce the value of TMS by 0.5. Not just 0.5, can even set 0.4, 0.3 also. Just as an illustration or example you can say. So 0.5, let us say for the same operating time multiply means it will be what in terms of 2 seconds. See, 4 into 0.5, it is 2 seconds. Earlier it was taking 4 seconds for particular current, that is plug setting multiplier, but after setting TMS as 0.5, now it has become to 2 seconds. Similarly, if you want to reduce further the operating time of the relay to operate and all, if you want to set to 0.2 means, again 0.2 into 4 will give you 0.8 second. Again the operating time of the relay is reduced. If I increase the TMS, the operating time of the relay will be increased. If I decrease the TMS, the operating time of the relay will decrease. So the relay will be quick enough, you can say like that. Okay. So this ends your first module, that is Introduction to Power System Protection, Relay Construction and Operating Principles, as well as Overcurrent Protection. So in next class we shall start module 2, and that will be your continuation of your last chapter, that is Overcurrent Protection. So further this chapter is continued in the module 2, but here your module 1 ends.